All right, we are getting into our last chapter of this semester, chapter 5. We're switching gears a little bit, still mostly talking about triangles, but some different properties. So, in our warm-ups today, we're bringing back some of our old topics that we're going to need, like finding the length, finding the midpoint. We're also going to find the slope. How do I find the length of a segment given two coordinates? Distance formula. We need to know our distance formula to do that. Does anybody remember in general what it is? I'll squeeze it in at the top here. We're missing one part of it. Square root that goes over the whole thing. Good. So the square root of x minus x squared plus y minus y squared. So when we fill that in for the length of AB, big square root, what's going in for my x1? 24, sure. Minus squared plus 0 minus 10 squared. All right, remember to be consistent when you do that, meaning we started with the 24 for our x's, so we had to start with the 0 for the y. If you had done it the other way around, started with your 0 for x, then you should have started with 10 for your y's. It doesn't matter which way you do it as long as you are consistent. All right, under our radical, 24 minus 0, 24, square it. 576 plus 0 minus 10, negative 10. Careful on this part. When you square it, positive 100. Add those together, we get the square root of that is 26. So that would be the length of AB. Questions about finding length? That is something that we've done periodically since we've learned about it, so that should look familiar. One thing we have not talked about a lot since we learned about it is midpoint. Who remembers how to find the midpoint? Majay? Good. So to find midpoint, we add the x's, divide by 2, comma, add the y's, divide by 2. That gives us the midpoint. So for the midpoint of CA, what are the x coordinates that I'm adding together? 0 and 0. That makes it easy. What about the y coordinates? 10 plus 0. Okay, so 0 plus 0 is divided by 2, still 0. 10 plus 0 divided by 2 is 5. So the midpoint of segment CA would be 0, 5. Finally, we are asked for the slope of segment AB. Who remembers how to find slope? Good. y2 minus y1 over x2 minus x1. So if I'm finding the slope of AB, what's going in my numerator? 0 minus 10 over 24 minus 0. 0 minus 10. 24 minus 0. Reduce it. Very good. Thank you. Questions about finding the length, the midpoint, or the slope of a segment? If any of these topics were unfamiliar, I would recommend having the generic form for doing them written down. A midsegment of a triangle connects the midpoints of the triangle. It's kind of self-explanatory. The midsegment is a segment that connects midpoints. Every triangle has 3 midsegments. So in our picture, we could label all of the midpoints. So I'll call them midpoint 1, midpoint 2, and midpoint 3. So our midsegments connect those points. So there would be 1, 2, 3 midsegments inside any triangle. Questions about what a midsegment is or what it does? Okay, so let's talk about why they're special. The midsegment theorem. The segment connecting the midpoints of 2 sides of a triangle is parallel to the third side. Parallel meaning it has the same slope. Okay, same slope as the third side, and is half as long as that side. So it's parallel to the third side, it's half as long as that third side. Okay, for these, DE is a midsegment of triangle ABC. We are asked to find the value of x. What do you think it's going to be on letter A? 16. It's half as long as that third side that it didn't touch. So 32 divided by 2 makes it 16. Now, don't get tricked by that when we move on to letter B. What's going to be the value of x on letter B? 8. Because if DE is a midsegment, then both D and E are what kind of points? Midpoints. Okay, so these are still midpoints. We don't need to forget that when we move on and do different types of examples. So you have to remember these are still midpoints. So that means it splits this side equally. But if we're talking about a mid segment on the inside, then it's half the length of the side that's kind of across from it or that it does not touch. These should be really easy problems. It just gets tricky when we confuse the ideas. Questions on example 1? Okay. All right, let's move on and talk about coordinate proofs. Coordinate proofs involves placing geometric figures in a coordinate plane. When you use variables to represent coordinates of a figure in a coordinate proof, the results are true for all figures of that type. So we are asked to place each figure in a coordinate plane in a way that is convenient to finding the side lengths. Assign coordinate to each vertex. Now, notice there are no numbers here, so we are going to be attempting to do this without using any actual numbers, just with variables. So if I am asked to place a rectangle somewhere where it would be easy for me to identify the side lengths, do you think that I want to place my rectangle somewhere in the middle here? Where's it going to be easiest for me to place it? On the axes. We want to use these axes as much as possible. So doing that, we could have one side of my rectangle here, I probably want one of my corners to be at which point? The origin. That's going to make this easiest on me. So if I place one edge on the y-axis, one edge along the x-axis, and try to make those a little bolder so you can see them. That's probably a little too bold, but that's all right. Okay. Then we can complete the rectangle at the top and at the bottom there. Does it make sense why this would be the easiest way to place it so that I could identify my side lengths? Okay, so if I'm then labeling my vertices of it, we said this bottom left corner is at which point? The origin, or 0, 0. So my point down here is at 0, 0. Now I kind of covered up my axes when I made my line a little bit bolder, but this is my x-axis down here. So this point all the way out at my other bottom vertex. How could I describe that point using coordinate notation? What? I know, I just didn't hear you. 0y is going to be the point on my y-axis. So 0, y would be up here. So you're on the right track. X, 0. We go out X spaces. We did not go up or down. So then the last corner that we have to identify is the one that has both an X and a Y. What do you think it's going to be? X, y. So again, your rectangle might not look exactly the same as mine. You could have made yours taller instead of longer. That would have been fine. It really wouldn't have changed how we name the coordinates though, since we're not using any specific numbers. Go ahead and see if you can do the same kind of thing with a right triangle on letter B, including naming your coordinates. If A made sense, B, in my opinion, is even easier because you only have 3 instead of 4 coordinates to name. All right, when you did this, hopefully you still use the origin as one of your points. And that way you could use your axes as your legs to make that right angle. Whose triangle looked something like this. Good, it should. Okay, if you placed it somewhere else, it's going to be a little bit trickier to identify your coordinates. So my bottom left corner where that right angle is, what are my coordinates there? Good, 0, 0. What about the top left? 0, y. And bottom right, x, 0. Questions, concerns? Okay, so let's try to do this. Place an isosceles right triangle in a coordinate plane. Find the length of the hypotenuse and the coordinates of its midpoint. So, we're again placing a right triangle in this coordinate plane. But if we want it to be isosceles, what needs to be true about it? Good. 2 sides are going to be the same. Which 2 sides specifically? The legs, which are going to be on the axes. Because remember, the hypotenuse is always across from the right angle. So if we're using our axes to form that right angle, then those legs are the ones that need to be congruent to each other. Okay, and we can draw in our hypotenuse across from that. Now, before we start worrying about our distance formula and our midpoint, let's talk about what these coordinates are going to be. So we know down here, bottom left, that's still going to be 0, 0. Let's go bottom right. That one's going to be what? X, comma 0. Now, so far, what have we been calling the top left? We've been calling it 0y, but what needs to be the same about x and y this time? They need to be the same number. Does that make sense? So instead of calling it 0, comma y, we could call it 0, comma x, because we need them to be the same. Or you could have changed them both to have y's instead of x's. Either way, the x and y values need to be the same if this is going to be isosceles, making those congruent to each other. So I'm going to stick with x. If you prefer y, technically it would be fine either way. Bless you. Questions about how we decided on these coordinates? Okay, so then we are going to use those coordinates to find the distance of my hypotenuse. So 0x and x0 are going to be the coordinates that I'm using. So my distance formula, when I set it up, distance equals square root of. I'll just set up my whole skeleton of it to begin with. Which x coordinate do you want to start with? So remember for the what? But this point? Okay. So if we start with this bottom point, what's my x coordinate from my bottom point? X. What's the x coordinate of my other point? 0. Okay, then we started with this bottom point. We got to restart with it. What's the y coordinate from this point? 0. Now this is going to sound weird to say. What's my y coordinate from the other point? X. Questions about how we plug these in? Okay, so then we find the distance. We can simplify this. X minus 0 is x. If we square x, what do we call it? X squared. Plus negative x, but if we square it, it's going to be, what's it going to be? X squared, positive x squared. If you take x squared plus x squared, what do you get? 2x squared is what I'm looking for. If you add like terms, you don't change their exponents. We only change exponents when we multiply or when we divide or when we take a power to a power. But if you're just combining like terms, you don't change that exponent. Technically, we can simplify this. I would accept it. If you were to leave your answer here, it would be okay. Technically, this is the same. Well, does anybody know? Close. The x would come outside because there were 2 of them, so you could take 1 out. What would be left underneath?
2x.
Just a 2. We used up all the x's. Okay, so if we were to break that down factor tree style, we would have a 2 and an x squared. The x squared breaks into an x and an x. Whoop. And then that pair, one of them comes out, the 2 is alone, stays inside. Okay, if you were to get it to square root 2x squared, I would technically be fine with that. That's pretty close. X root 2 is the best possible answer. So what this is allowing us to do is if we have any isosceles right triangle and you know the length of one of your legs, all you have to do is plop that number in for your x, and you have the length of your hypotenuse. without having to do Pythagorean theorem, without having to redo your distance formula over and over again. So that's what the whole goal of this is for. I understand it seems tedious and obnoxious, but the goal of this is so that you can have a generic situation that you could apply to more specific situations. All right. Midpoint, we're going to do the same idea that we just did for distance, but with midpoint. So for midpoint, remember we add our x coordinates divided by 2, add the y coordinates divided by 2. So again, what were my x coordinates? X and 0, and my y coordinates? 0 and what? X. Okay. Remember, x and y in this case technically could have been used interchangeably. So here we would have x over 2, comma, x over 2. Which should make sense that the midpoint would be halfway along there. Questions, concerns about finding our generic situations? We ready to try one more? Are we wishing for regular proofs to come back?
No.
No? Even with this nonsense?
So easy.
We'd rather do this? Oh, all right. Well, you do have to take a final, so there will be proofs on that. All right. Place a rectangle in a coordinate plane. Find the length of a diagonal and the coordinates of the midpoint M of the diagonal. So when we do this time, we're not going to be able to assume that x and y are the same because we don't know that it's isosceles, or in this case, we don't know that it's a square. All they're saying is that it's a rectangle. So much like we did up above, just put in your generic rectangle. If you would rather have it go long ways instead of sideways, that's fine. I'm having trouble getting mine to square up. Still. Let's make this easier on me. That's a little bit better. All right. We've got a rectangle. Let's identify our coordinates real quick. Bottom left is going to be 0, 0. Top left, 0, comma, y. Bottom right, x, 0. And top left, x, comma, y. They want us to place a diagonal in there. Now, technically, you can choose which diagonal you want to place. Do you want to place the one that starts at the origin and goes to xy, or do you want to place the one that goes from 0y to x0? Okay? It doesn't matter to me, and honestly, it should turn out to be pretty similar either way we do it. So if we want to do the one that starts at the origin, that's fine. Okay, the length or distance should come out the same. The midpoint should come out the same. So it really doesn't matter. If you strongly prefer to do it the other way, your answer should come out the same. So I'm fine with you trying that. So go ahead and try finding your distance simplified and your midpoint simplified using those endpoints. See what you come up with. All right, when we used those points, what did we plug into our distance formula? Okay, x minus 0 squared plus y minus 0 squared. So when we simplify this, what do we end up with under our radical? Good. Can I change this to just an x plus y? No, because we have that plus sign separating them. So there is no way to simplify that radical. It would have to be x squared plus y squared all underneath the radical. Anybody get that? I know a couple people did because I heard some people say. Good. If we did not end up with that, do we have questions about where we stopped, where we got confused, what we did wrong? Yes, ma'am. Like get rid of your radical somehow? Nope, that's what I just said. Because they're separated by that plus sign, we can't do it. If they had a times sign there, then we could, but not with a plus sign. Other questions? Okay. What about for midpoint? We could probably just go straight to our answer, honestly. What do we get? X over 2, comma, y over 2. When you add 0, it doesn't really change anything. So just x divided by 2, y divided by 2. Again, both of those should have been the same answer if you had done the other diagonal. Same distance, same midpoint. Not for a while.